everyone, and welcome to Schrodinger's Bathtub. This week, joined by Almost a Doctor, Matt, and we're going to be talking about things that go boom or stink out your house or eat through everything. Oh, as well as things that can kill you.
Well, I mean, if they can eat through your bathtub,
they can pretty much kill you, yeah.
Through you.
Well, yeah, most of these things can and will kill you. Not all of them. There are one or two that won't kill you, but you will wish you were dead anyway.
I've got one or two that are a bit safer, hopefully, that we can bring up towards the end. But I know what everyone's here for. Everyone wants to know what goes boom or does the good at dissolving.
Yeah, I mean, if you're starting off with the booms, you've got your sodium and your potassiums dropped in water, which are basically a reaction within the water that releases a lot of hydrogen. Potassium's a bit more reactive than sodium, which is why once it releases enough hydrogen, it gets hot, and then the hydrogen ignites, and you get your nice big hydrogen explosion, basically.
Yes. It's also one of the methods you can use to make meth, uses hydrogen as one of the reagents.
Oh, that's awesome.
But the catalyst can spontaneously combust in oxygen if you've got that set up. So if your setup leaks to the air, it just... So don't make meth, kids.
Yeah. And just to let you all know that there's going to be a lot of fees in this show. And I've got toys to play with. Matt already knows. He's seen them all.
I've seen some of them at least.
He has.
And I'm sure there'll be more in the future. As well, so.
As we do more of these things, there'll be more things added as we feel like adding them. In case anybody was wondering, Matt will probably quite often be a co-host with me on this, because we both love science, we both love communicating about things, and we just like having a bit of fun. So I'll try and keep track of the chat whilst we talk about this thing. If you have a question, we'll pop it up and we'll repeat it. And yeah, but I'll let you go. I'll let you go first, Matt.
All right. Well, I guess that depends what area you wanted to start with, because I've got a few chemicals I can talk about. We've got radioactive, we've got poisonous, we've got corrosive, we've got flammable and explosive. So do we want to start eating?
What did the chat want us to start with?
What do you want to hear about? I've got all sorts of things.
I'm betting they want
concrete.
I bet they want
glass.
I'll almost guarantee the chat will go boom.
Unless they want to hear about how you eat through a person.
Oh yeah, well that's something.
Yes, let's try not to actually.
So whilst you guys are deciding what you want to do, hi to Chris and Chris, Sandy, D3, to Jade, and anyone else I've missed in that. Dog, hi to everyone in the chat down there. Raven, I know you're there. I remember seeing it before. So. Hi to you all. Well, Chris has voted for explosives, and he's the only one who's said anything yet. So shall we start there? Well, we kind of did, because we talked about potassium and sodium, which are reactive in water. Yeah. But there's a lot more reactive chemicals than those compared to a lot of the other chemicals out there. They're babies. They really are.
They are. Now, there's two things that you want for a good explosive. Now, everybody thinks of fire when you think of explosives, and movies are really good at showing that. They're actually too good at showing that.
Movie explosions are just so wrong. Yes, go check the video out on Matt's channel. It's brilliant.
Obviously, stay here for this one, though.
After this stream.
But yes, there's actually two things you want. The first one to do with fire is enthalpy, or just another way of talking about energy, which in terms of an explosion is just heat. We want the reaction to go from some high energy state to a low energy state and release all that energy out into the wild blue yonder, although it might not be blue for much longer, depending on what we're dealing with. But the other one that's a little more subtle is we want to favor entropy. Now, entropy is that weird term that you've probably heard thrown around, and it basically means disorder. But in terms of explosive, that means going from fewer molecules to more molecules. So if you've got one molecule of your explosive, you want to get as many gas molecules coming out of that, because it also does another thing. It gives you a nice expansion that gives you that shock wave for the explosive. So you want things that will meet both of those. Lots of energy and lots of gas coming off. And one of the things that's really, really good for that is nitrogen. Nitrogen bonds are fairly weak when they're in organic compounds, but as soon as you have nitrogen-nitrogen bonds or nitrogen-oxygen bonds like nitrates that you find in the air, they're much, much happier. They're quite strong bonds, lower energy. So not only do you get lots of gas with nitrogen, you get lots of energy. So the first chemical that I think we could bring up... Which is why
nitrogen is a restricted substance in most countries.
Yes, it's why you because you can use it in so many explosives. Like if you think about most of the common explosives that you're going to hear about, you'll think about ones like nitroglycerin. There we go, got a nitrate. Cellulose nitrate or gun cotton, TNT, trinitrotoluene, and of course, I've done nitroglycerin, but dynamite is just nitroglycerin mixed with a particular type of clay. So.
Yeah, you read that, did you?
Actually, yes, I saw that. One of the best ways to actually stop an explosive is to put it in a vacuum, because that gas just you can't get that pressure wave because it just fills the vacuum. But so we think of those explosives and we think dynamite's pretty explosive, and it is, and gun cotton's pretty explosive. But I mean, it's the same stuff as magician's flash paper. It's nothing. Not that I would ever know that from experience. But the one that I like is azide. Now
I hate trying to say that word.
Kind of structure 3 times in a row, and I shall bring up the chemical structure for it in a second. But remember, keeping in mind, I said nitrogens are pretty good. I mean, nitrogen carbons are not too bad, but this one here, this. So I wonder if that should come up. Are we good, Jen?
Yeah,
yes,
we're good.
There
I'll
we
be
go.
there in a sec.
So as you can see, this one has lots of nitrogens, and it is incredibly explosive and as unstable as they come. You probably won't get something more explosive than this. The list of things that can cause this to explode is quite extensive.
Yes.
Sudden impacts, rapid changes in temperature, slight changes in temperature, looking at it pretty much will blow it up, and my favorite one, absolutely nothing. One of the teams that first made this had it in a climate-controlled room, so they're monitoring the temperature so that it's incredibly stable. It was in a shock-proof container in a non-reactive drum, and it still exploded. This stuff will just blow anything up.
It is just so hyper-reactive with absolutely everything.
In other words, like if you look at this thing the wrong way, it'll blow up in your face. And as I'm still not fully understanding why, but it's not very well studied. They don't know a lot about this compound, and
I can imagine why it's not well studied. Yeah, like. I mean, how many fingers do you want to have left? That is the big thing, isn't it?
I guess it depends which fingers are left.
We'll catch you later.
But it's not the only one. Like, that's just explosive. But if we want more cool and burny ones, we could go there next.
Oh, we definitely could. I mean, there's a couple of really good burny ones. I don't know. Do we want to save the big one till the end, or should we go with it now?
Maybe we can save the big one to the end.
We'll save the big one to the end. But I mean, everyone knows about thermite, which is basically ground.
Yes, we can start with.
We can start with thermite because it's basically ground aluminium with an oxidizer in it. God, damn it, can't talk today. That when you apply enough heat and flame to it, it basically just burns, and it doesn't stop until it runs out. And it burns incredibly high temperature. It's about 2,500 degrees, isn't it? When it, I'm going off the top of my head. It's about that. It's pretty hot.
I've actually seen it. Thermite reaction. They used to use it for welding railway tracks together because it was so so hot that you'd seal the metal. It'd melt any metal. We actually had it done in one of my lectures as a demo. We had the fume hood up the front. No one was allowed within a few meters of this thing except the lecturer. They had a giant ceramic pot that they put it in, and the reaction was so hot it melted the ceramic pot and broke it and was dripping out the bottom.
That's what we had, but ours was in high school. We had a teacher in high school who decided it'd be really cool to demonstrate thermite to the students, and we did it outside. No fume hood. We did it outside on a concrete slab inside a flower pot, and it burnt through the pot into the concrete. Needless to say, they never did that again.
I heard stories once of this was decades ago when it actually happened, of someone at a particular research institute where they would always end up with leftover sodium, plain metal sodium, which is very reactive. And one of their ways to get rid of it was to drop it off the Manly ferry that runs across Sydney Harbour. And then they'd watch it explode. Oh. So they just drop it in, and then it'd float, and then the water would get in, the hydrogen would be formed, and then
Triple D has said that manganese is often added to thermite for railway welding. I've seen that. Manganese. So I mean, I'm assuming it works like a mental blank. We'll forget. I was saying to say something. I've totally forgotten a flux. I'd assume it works like a flux to help with the welding process when they add the manganese into it. But
imagine the manganese might help stop rust as well.
It helps harden it quicker. Okay.
Oh, okay. All right.
See, I can learn. I'm good at learning.
The one thing science has taught me is that I don't know anything.
Yeah, no. As soon as we've had to look most of these up, even though we've known them before. But it's it's hilarious. It is funny, but it's also really serious.
Yeah, you don't want to mess with these. But to reply to Dog's comment for a minute, if I start telling you how to make these explosives, I'm sure someone's going to be knocking on my door.
Not only that,
all my friends think I'm
on
on government watch lists. But the amount of times I've been checked for explosives at airports, it's not random.
It's not random.
80-90% of the time I try going, even domestic, they're like, can you step over here, sir? It's never drug tests. They're never looking for drugs. They're always looking for explosives.
I'm guessing this is one of your mates.
Yeah. Yes. Hey, Nick. How you going?
Hi, Nick. Nice to see you here.
Kettle, Manhattan Project was to do with nuclear reactions. At the moment, we're talking about chemical, but if you want to get to radioactive ones, we can a bit later.
We can do that later. Well, we kind of are going to get to that with one of the other ones. So if we were going to talk about things that eat things aside from thermite, so give me a sec because I've got so many screens open. But
one of the things though, I did make a video on it recently, but there was an idea that you could use controlled explosives or explosions to actually generate power, was because we don't have working fusion reactors yet, but we have fusion bombs. We've got hydrogen bombs. So the idea was, why don't we just put some hydrogen bombs underground, set them off, and use the heat generated from that to power some steam turbines? And before anyone realized that setting off nukes every day continuously would probably not do much good for anything.
Anyone much good, really.
But it was a serious project. They took it seriously. It was the 70s. I forget the project name, actually. But there was another one to use nukes to get us to space, which of course was a video one, which is why I know about it.
Yeah. Well, they tested
Project
that
Orion.
with Project Orion, and they tested that with conventional explosives to see if it will work.
Yeah,
and some of the new laser launch systems actually are based on some of the research they did with that. Because what the lasers do is they fire up into a concave mirror, and the mirror directs all the laser power into one area, and it heats up the air underneath, which causes an explosion, a rapid expansion, so like an explosion, and that pushes the ship up. So they got some of the data for how to do that from the Orion project, where they were mucking around with conventional explosives. But let's talk about after thermite. Let's talk about chlorine trifluoride. Now,
yes, chemical N.
Chemical N, yeah, substance N, as the Nazis called it, who discovered it during the Second World War, obviously. They were going to issue it to their soldiers to use to melt through Allied bunkers. Now think about this for a minute. This substance
bunkers,
is thick. So reactive that if any of it gets out of its container, it can basically burn through anything. Apart from the handful of materials, and mostly they're Teflon coated, that they have to put it in.
I think you could you store this one in metal? I think
there was some type of metal. There was some form of metal that you can, because it will react with the inner side of certain types of metals and create a layer that then it can't burn.
Was it alien? No,
the chlorine reacts with the inside of the container and creates a surface.
Yeah, it basically creates a layer of like rust on the inside of the container.
A chlorine-based
quickly
rust.
that it can't get to the rest of it. That's actually why aluminium doesn't rust, is because the outside rusts over, but it seals, and so nothing can get inside
and it's not a horrible brown rust.
Yeah, this stuff could melt through concrete. It could also set fire to asbestos, which was used as a fireproofing for buildings for decades. So it set fire to stuff that shouldn't burn in the first place.
Exactly.
And it was so nasty that the Nazis decided it was too
dangerous to use. If the Nazis decide it's too dangerous, we won't use it. However, the US stepped up. And they actually... they made a ton of this stuff and had it stored inside a specialized tanker, because they were going to ship it somewhere to use it. And they crashed the tanker inside the warehouse where they had the stuff. And not only did it eat through the carpet, it ate through a layer of dirt underneath the carpet concrete. It ate through the concrete.
Yes.
And a meter of dirt underneath the concrete.
Yeah, it burnt through the floor of the warehouse and then into the ground. So they came back to find a giant hole, because you can't put this stuff out.
Yeah, it's one of those...
It just keeps burning.
This is one of those weird chlorine chemicals where when exposed to oxygen, it's the oxygen that burns and not the chemical. So this can actually have oxygen being the thing that's burning, not being the oxidizer.
Yeah, so when they told you that, you need 3 things for a fire and one of them is oxygen, no, this thing is all you need.
Yeah. Which is why it can burn through anything.
The other 2 things.
Yeah. Don't have water yet.
It'll make the other 2 things. And if anyone's wondering what it looks like, it's this one here. It is a very simple... I think that's it, isn't it?
Yeah. Yeah, trifluoride.
That one's it. Yeah, it's a very simple chemical, but fluorine and chloride don't really like being bonded to each other, so it's not very stable, and they're all compounds, elements that really like to bond to other stuff.
And really like to hurt things. Because you got chlorine and fluorine. It's like, let's get the 2 worst things we can think of and meld them together, because we're nice.
Yes. Because that will come up later, and I don't know whether we want to use this as a transition, but some of the other chemicals we got on the list for actually doing like acid or corrosive damage. Love having these 2 chemicals.
Fluoride. Well, shall we go to the strongest acid known to man?
Oh, yes. I'm not sure I have a diagram for this one, but
you can say its name because I always get these wrong.
I got to make sure I've got the spelling in front of me because, I'm not great with the pronunciation. Fluoroantimonic acid. So I will try and find a diagram for that, but you've got one single atom of antimony in the middle surrounded by fluoride. It is 20 quintillion times stronger than sulfuric acid. It's so acidic that it acidifies sulfuric acid.
Yeah.
Now, the fancy term for that is protonates. It actually puts a proton on sulfuric acid, but for those who don't...
Which is quite impressive when you think about it.
That is, you don't need to. Yes, it's so strong that it will eat sulfuric acid. It's not the most, but it's the strongest acid, but it's not the most acidic compound in the world, if that makes any sense. I think it's the strongest acid, it's the most dangerous acid, but there is another acid that will more readily give up its hydrogen, but we can get to that because that one is not as dangerous. This other one, I gotta find that. There's a few that are like that, but this one here is like insanely bad because apart from Teflon, you can't store it in anything. But the reason this one is now acids are defined as what's known as electron pair acceptors, I believe it is. They're acceptors or proton donors. All that means is they give up a hydrogen. So this one gives its hydrogen up, but it's not that makes it so dangerous. It's what's left after you've given the hydrogen. The fluoride and the antimony left in that molecule floating around will pretty much attack everything that it can come across, particularly bone. So this thing, if you get it on your skin, will eat through your skin, get to your bone, and then be more happy and keep going. And so you might think that other fluoride acids are just as bad, but they're not bad in the same way. One of the worst chemicals to work with, like if you actually talk, like I've actually spoken to people in a burns unit about this, their worst burns come from HF or hydrofluoric acid. It's not a very strong acid. It's the same thing you see in Breaking Bad, though, when if you want to dissolve a body. So yes, kids, if you want to dissolve a body, this will kind of do it, but not as well as Breaking Bad shows. You probably want the fluoroantimonic acid. But HF is nasty. But
also that would dissolve your bath unless you've got a Teflon-coated one.
Yes. I'm not sure about ceramic. Probably eat through that as well. I think that happens in Breaking Bad. I haven't actually seen it, but I think I've seen like the clip from that scene. I believe the Mythbusters tried this one.
They use it for cleaning certain things.
It's also really good for reactions. So where I working for my PhD, there's the nanoscience building behind us. They have a clean room, so those are the proper ones with the ventilation, so they don't have there's no dust in them basically, and they work with HF. So there are ways to deal with it, but HF is nasty because if you spill it on you, it won't burn you instantly. So you'll spill it on yourself, you'll be like, okay, let's rinse it off. What it will do though, it'll get through your skin, it'll work its way down without doing a lot of damage initially compared to, like sulfuric acid will do more initial damage.
Yeah.
It'll get to your bone, then the fluoride will see the calcium in your bone and be like, that's mine. And then it will start eating you from the inside out. Yeah. So this one, one of the nurses in the burns unit, when I ended up there once, which we can also get to if we want toxic stuff, he said, we don't give anesthetic to people who have HF burns because the only way to tell when the antidote is working is when they stop screaming. These acids are not a joke. They will just rip through everything. Particularly fluoride, because it just likes to react with everything. So it's not just the actual proton they're giving off the hydrogen, it's the... yes, although to go with Dog's comment, I could also add that bleach is a very good way to get rid of DNA, but the bleach is not that exciting.
No, it's pretty boring.
There's different types.
Unless you drink
Just don't drink it. Exciting is not the term I would use for that. But there are nut jobs out there who actually say drinking bleach is worth it. What was the one? Oh, I was watching. There's one channel who likes to take the piss out of them that I was watching. And he was looking at one guy who was talking about that. No. It's like, no, this is how you prepare your bleach, and if you put it with sugar, that's even better. I'm just like, no, it's still bleach. And there was another guy who was trying to claim, there's probably a lot of them, someone who's trying to claim that, was it pine essential oil or turpentine, because it's an essential oil, can't be that bad for you and you should drink it in small quantities to kill all the bacteria inside you. There's only one part of that sentence I kind of agreed with, and that was, it will kill the bacteria inside of you, but it will also kill you. So yes, there are somehow people out there who think it is funny.
If we're going to talk about chlorine and things that people drink, what about ethylene glycol?
So if we want to know where our modern laws come from as to food and drug, particularly the FDA in America, if we want to know where that came from and why you actually need to clearly label poisons on bottles, was because of a particular story back in the 19th century in America with ethylene glycol, otherwise known as antifreeze, the stuff that you put in the car so it doesn't keep
the green stuff.
Yes. Now, there was some company that in America thought that we will sell this as an elixir to help cure disease, including the symptoms of common cold and drug abuse, all these things, and they sold as this lovely elixir. But it said on the bottle, one of the instructions were, if symptoms persist or get worse, increase the dose or keep giving until symptoms get better. The problem was the symptoms they labeled on the bottle were also the symptoms that you get when you drink ethylene glycol. So what happened is people would start giving the ethylene glycol, and that would make the person sick, and then they'd start giving them more because the bottle said. And the thing is, the law in America said, as long as you said what was on the bottle, you could sell it. So as long as they said there was ethylene glycol in it, they could say it was a medicine. What they got them on was the fact that they called it an elixir, and there is a very specific definition of what an elixir is. So they got them on that, not the fact that they'd actually put poison out and sold it as a medicine. But because of that, they... Please, Kettle, don't mix antifreeze with your dinner.
Yeah.
You won't be able to tell it apart from the peas. No, it's not green, is it? I've worked with glycols and
they colour it green in antifreeze.
Yeah,
which is the problem.
But I think the colour's just
ethylene glycol is sweet tasting. So and it went. I mean, if it's slightly mixed down with water,
that's what they're putting it in
thin.
They're putting it in the medicine to make it taste better. Because it had the sweet taste. That was why it was in there in the first place.
But it's not just that. We still have problems with this now because you've got a jar of something that's green and not very thick in a workshop, and it tastes sweet. You get kids in workshops and they will drink this thinking it's a cool drink or something like that. It's a cordial or something. But it's ethylene glycol. And animals do this too. Dogs will knock them over and then drink all the fluid up, and then because what it effectively does is it oxidizes in your stomach and converts into an acid, a rather powerful one. And it has a cytotoxic effect as well. So not only do you start eating yourself out from the inside, because you get a lot more extra acid in your stomach that your stomach's not capable of dealing with, it's also a toxin. So yeah,
it's also it's like a double alcohol, but you don't actually want two OH groups on your alcohol. This stuff, I think they also tried using it to help people with dealing with alcohol addiction, because they thought, oh, it'll taste sweet and it has a similar effect, but it'll make you sick, so that you won't feel like drinking again. But it only ended up doing us a serious amount of damage. Yes. So, the reason we have a lot of these rules is because, we fed this to people, or people fed it to other people, and it's scary when you look at how lax people used to be.
Yes, Raven, it is why dogs drink it. And Nick's not going to give up on you tonight.
No, I'm expecting nothing less. Green Gatorade. Try Goonerade, Nick. It's even worse. Actually, will the Americans get that? I don't know. Do they know what goon is? Or is that just an Australian term?
I'm not sure. We'll have to ask the Americans in the chat.
If, for the Americans in the chat, do you guys know what I mean when I refer to a particular drink as goon? I know all the Aussies here will. So yes, Goonerade is exactly what you would expect it to be once you know what goon is, and Gatorade. But yes, so ethylene glycol, it's not as nasty as other chemicals, but it is not friendly. And we used to give it, and it's similar approach to when the US had prohibition. They started adding methanol to their industrial alcohol, because people were taking the industrial alcohol to make mixes out of it. They just pour it into a drink. So they decided, let's actually put a poison in there that will kill people so they don't drink it. Yeah. Really, really underestimating people's desire to drink alcohol. So you can distill it out, but if you don't do it properly, you end up with methanol. And methanol you don't need much of, because it doesn't leave your body. The formaldehyde will just bond with particularly your retinal cells. That's why when you say you get blind drunk, it actually comes from before the days that they could separate the methanol as well. And if you drank too much, it would bind the retinal cells and you'd go blind. And if it was for long enough, it's permanent. But the cure for that, one of the things if you end up in hospital with methanol poisoning, is they flood you with ethanol. So they just gave you proper alcohol, because it actually helps flush out the formaldehyde. So it's one of the ways to get rid of methanol is to treat with ethanol. But I guess ideally we don't want to be consuming any methanol in the first place. But that's why you got to be careful with distillation. So yes, chemicals can be nasty. They can be pretty too, but that doesn't mean you should
warning people, chemicals can be nasty.
Yes, I think if you talk to any chemist, they will probably be a walking example as to why you shouldn't underestimate chemistry. I only made that mistake once.
Yes, only once, and you've still got the scars to prove it.
I do. They won't show up on this camera, unfortunately. No. It's not high enough resolution.
But my hands,
I have, and my hands are different textures because of a particular chemical. So, I imagine that's probably the segue into the next one. Mustard chemicals, including solid and gas forms of mustards. Most common things when we refer to a mustard is not the stuff that you spread, and it's not even close to the stuff you'd put on your food. Yes, you'd hope not.
I mean, the main reason was the colour of it, wasn't it? That they called it mustard gas.
I would believe so, because they were the first ones they come up with were nitrogen based, and nitrogen tends to be very good at making brown colours.
Yeah.
So that kind of those yellowy browns. that you see as mustard. So there's mustard gas. So this was actually the chemical unit that started releasing these. I think was actually Captain Fritz Haber's division that did this. I'm not 100% sure. He was the guy who also came up with the way that we make artificial fertilizer, but also came up with Zyklon A, which was the precursor to the chemical Zyklon B that they used in the death camps.
Yeah.
So yeah, it's not a friendly beginning, but he was in
the things we do
very
in war.
Weird chemist. Yeah, well,
considering quite a few of these chemicals were actually made during the Second World War, it's like. Yeah.
Yeah, well, all the first, because these ones are first.
All the first,
And surprisingly, they weren't used in the Second World War, because Hitler was actually gassed in the trenches in World War I, and so he didn't want to use it in World War II because he knew how nasty it was. which kind of says a lot about what he thought about certain groups of people then, that he wouldn't use it on what he thought were humans. Yes. But these chemicals, what they do, they're very particular. They look in a particular way. They have a nitrogen, if they're a nitrogen mustard, a sulfur, if they're a sulfur mustard. Then you have a bond to a carbon, then another carbon, then a chlorine. Now, you don't necessarily even have one of these branches. You have multiple branches. So if you want to make most basic nitrogen mustard, you have a single nitrogen in the middle and you have 3 of these branches coming off. What happens is the chlorine or the halogen you got in the end buggers off, and you end up with a positive charge that finds the nitrogen or the sulfur, and you end up with this nice little triangle. So this chemical confirms the Illuminati.
You're all going to notice a theme here with most of these chemicals. They've got one of the big 3. They've either got chlorine, fluorine, or nitrogen.
Yes. And these ones, well, when you form this nice little triangle with that charge at the top, is very good at binding to, amongst other things, DNA. So if it gets into your skin, if it gets into your cells, it will mess with the DNA, which means the burn takes a long time to notice.
Yeah.
So unlike when you think about like acid burns that are fairly fast, these aren't. So, but it's also one of the reasons why there's such a nasty chemical in warfare, is that once they get onto your skin or you're exposed to them, they'll get through into your cells, and you can't wash them off. And so they'll bind with the DNA, they'll mess the DNA up. So several hours later, when the cells go to replicate, they can't, and that's when the damage is done. So I think if it's considered a severe burn if anything shows up within an hour. Wow. Which was not how lucky I was when I accidentally spilt one of these chemicals on myself in a research lab. It took 6 hours before anything showed up for me, and it took 4 days to stop
it burning.
Yes, and even though I washed it, there was nothing you could do once it gets into your skin. So these are unfriendly ones. But they also they also tried to use them for dealing with cancer. There is a lighter side. There was a while where they were looking at these mustard chemicals, but much more fancy ones, bigger ones, that still had that nitrogen at the top with the little side, like antennas sticking out. And
like little aliens.
Yeah. And they realized they could use this as a possible anti-cancer agent it was shortly after World War I, somehow by complete accident, which I struggle to think how this could have been an accident to occur anyway. Someone accidentally released mustard gas into a hospital. This was after the war. I don't know how that, why was there mustard gas near a hospital? Why?
That's kind of weird. Why would you do that?
I don't get how that was something that could occur, because it wasn't a medicine at the time. No. It still isn't. But a lot of the cancer patients felt better. And they realized that the mustard chemicals were really good at killing cancer cells. The reason we never actually made any anti-cancer drugs out of this was it was so good at killing the cancer cells, but it was also good at killing everything else. So it was...
It does.
Yes. So in the same way that bleach is good at killing bacteria, still doesn't make a good medicine.
I think now that you've gone to things that do cancer and stuff like that, that's a great segue into one of the other ones, which is... where are we? On my list. Chlorine trifluoride. No, that's one we just did. Dimethyl cadmium.
Oh, this one.
Dimethyl cadmium, which is considered the deadliest chemical in the world.
Is this the one where it's like a drop of it in the same room as you and you're in trouble?
Yeah, it's considered by most chemists to be the most toxic chemical known to man. Because cadmium is lighter than mercury, and the organic compound is more volatile, so it absorbs straight into your bloodstream and rips apart the organs that need the biggest supply of blood. So basically, it attaches itself to your blood, moves around your body, and starts tearing your organs apart. That's good. So that's good. But you can survive that. if you get treatment, you can actually survive that. But by some miracle, you may actually survive that. But the danger isn't over, because diethyl cadmium is also one of the most carcinogenic substances in the world. So if you happen to somehow survive the initial attack on all your internal organs and you get medical treatment, it's going to get you in the long run because you're going to die from cancer. We're laughing about this, but it's just, you got to laugh about it because these things, people have actually made them and people have experienced this, and it's dreadful. But if we have to laugh about it because it's like, if you don't laugh about it, you're gonna go, what have we done to our world?
Yeah, it's kind of laughing to hide the pain in a way. It's like these things are really, really, dangerous chemicals. Some of them, though, have some slightly more.
But we haven't got as far as it goes because it also explodes in water. So if you've got water,
don't try washing it.
And there's a lot of water in our system. So anytime it comes in contact with water within the human body, it goes boom, and you get little explosions, which is why it can tear the organs apart. So
isn't also the compound that it burns into is also toxic, isn't it?
Yeah, everything it touches.
So you're not done after that? No,
you're not done because it's C2H6CD. So basically it tears apart the carbon bonds within the body, and it leaves and puts cadmium in place of some of those carbons, which is why you end up with cancer in the long run. So basically, it starts tearing you apart from the insides, and even if you survive the initial tearing apart, you'll end up with cancer. So, and Dog says that's the same chemical that every animal in Australia injects you with when they bite. Rabbits, ducks with fangs, etc.
Yes, even the platypus here has venom.
And hi, African Humanist. By the way, she loves your name, Matt. Ethel loves you.
Yes.
Ethel loves your
quite
name.
readily sums up my position at the moment, but it's not a medical doctor. I will make that.
Yeah, he's a chemist.
I'm not
and
giving
a
medical advice here. Yes, but I do have a chemistry background, which is why I think this show works. Because Jen and I both have a science background. And I've spent time in chemistry labs, so. As I already mentioned, I've had experience with the sulfur mustards, but yes, as Kettle reminded me, yes, of course, the drop bears.
Drop bears. Well, we better highlight that one.
That's why, even though they're not.
By the way, Nick,
terribly
subscribe
big,
if you want to see Matt and I do some more stuff together like this, because it'll be fun.
And. Yeah, but the best way to keep drop bears away, I heard, was Vegemite. You just smear it. That's the only reason.
You smear it on their paws, don't you?
Well, they'll get it on their paws when they come through. But if you don't know where they are and you can't put it to their paws, you just put it on like around wherever you are. So if you got like a window you're worried about right next to it, you put it around the window. They won't come through the window. If you're like camping in the wild, you leave a jar, kind of put a little bit around the tent.
All right, so have we got the next one, Matt?
I'm trying to. Maybe we could try a slightly lighter one.
Should we go to Germany again? We seem to be heading back
time
there.
Here in Germany.
Yeah, we're spending half of this.
I did want to try like a little minor one before I think we go to the one you're talking about. Could we try phenolphthalein next? It's not one I put on the list, but it was one I was thinking about.
Oh, phenolphthalein. Yep.
No, this is phenolphthalein.
So different.
This is the. Oh yes, as James reminds me, you can also use toothpaste if you're out of Vegemite. But that's the only reason Vegemite sells well here. It doesn't taste that nice. It's essentially yeast extract, which I think it says everything you need to know about the flavour. But it's very useful for the drop bears and the venomous platypus as well.
I'm trying not to be rude this thing, but sorry, Vegemite is the reason why Australian males are so good at going down on women. Sorry.
I'm not going to comment on that because I can't think of anything to say that wouldn't make that worse.
It's a brilliant line, isn't it? It's either a go at my own sex for being very yeasty, or
that's not quite the route my brain was going down.
Oh, I was thinking chemicals and biological reactions.
After that comment,
Jay walked in just on that comment. Never mind, Jay. Never mind. We've actually we've been clean this entire stream right up until then, and I couldn't help myself.
Yes, up until then, we were only talking about how to dissolve bodies, burn through concrete, destroy enemy bunkers, and kill people with pretty much everything that's around you. Yeah. So yeah, you walked in at the wrong time.
So in comparison, lady parts that taste like Vegemite is fairly mild.
Thanks for the reminder. Someone is definitely clipping that bit. It's going up somewhere.
It's going up somewhere, yeah.
And not the Vegemite, but
that's what
anyway.
She said. Yeah.
but I was trying to make a small comment about the African humanist. I'm not that clever. I'm just educated beyond my intelligence.
Yeah, I go with that too. I'm educated beyond my intelligence. I read a lot.
So, phenolphthalein, or as you may have heard it said, phenolphthalein, although I believe the proper pronunciation is phenolphthalein, is much more mild on this list.
It is.
And it's basically just an indicator that goes pink. And if you're doing a titration, for those who have had to suffer through those at some point in their educational experiences, at high school or at uni, or having to teach people to do these, you call it beetroot juice when someone stuffs up and they add too much base and it just goes like beetroot.
Yeah, it goes really, really beetrooty in colour.
But the reason I bring this up is because nobody really knows how to pronounce the name, but it's used in high school still. It's used for titration competition. It's used in universities for titration. It's used all over the place. But what nobody tends to tell any of the students, although I love telling my students this, is that it's an incredibly powerful laxative. Now, the reason why this is a bit of a problem is that some indicators are very good at turning your urine very bright and weird and wacky colours. So some people have it in their head that certain indicators are good to drink. And I don't actually know which ones are good to drink because my brain on drinking chemicals out of the lab is don't. I've seen what I can do to what I've done to my hand. I don't need to do that to my insides.
Yeah.
So there are people who will hear about like drinking. Is it methyl? No, methyl. Maybe it is methyl orange or one of the other ones.
Where's Navadia when we need her?
Yeah, you could actually turn your urine bright green or blue, like all these weird colors, but you don't want to do it, like.
You really don't, because these chemicals, the reason they turn your urine that color is because they go straight through you. They don't react properly in your stomach, and they end up in your blood, and they get there as their original chemicals, so they don't break down properly, and some of them do nasty things to you internally.
Yes, but phenolphthalein, a single drop, like if you get a bit of it on your finger and then accidentally lick your finger even after the drop's dried, that's enough to send you running to the bathroom about half an hour later. And I actually tutored someone once when I was doing private tutoring who said that their mate decided to actually drink a bit in the lab for one reason or another. And then I told him but this stuff is really bad for your gut. And he was like, oh, that would explain why he wasn't at school the next day. So, yes. I wouldn't recommend doing it to someone you don't like, because there's a good chance they'll end up messing up whatever environment you're in with them. This stuff isn't... I mean, but it's more friendly than the other chemicals that we've talked about. But
that one's not really appropriate, but I thought I'd bring it up anyway. That one's not. It's not. It's inappropriate. It's just not in line with what we were talking about. So if we're going to talk about things that with accidents that happen in the lab, I think we have to make that trip to Germany now.
Yes.
Yeah, I really
most of the best scientific inventions out there, most of the discoveries that have been made have been made by accident.
At least pre First and Second World War. So at least we're there.
Yes, when you think about most accidents in a lab, we get things like microwaves when the chocolate bar melts in your pocket, or X-rays when you accidentally expose some photographic paper. But not this one.
No.
Jen?
Okay, I'm actually looking for it so I don't pronounce it wrong, and I'm betting I'm going to pronounce it wrong, so...
Acetylthiols. No,
that's it.
Yeah.
Acetylthylene. Because it's one... Ethylene or thylol?
Oh, no, I've got it around the wrong way. It's thioacetone is the one I'm looking at. Is that the right one?
Is it? Give me a second.
I may have put it wrong in the document by accident. I am looking at it, which is not a great... I was trying for a great lead-in and then can't even get the name of the chemicals that I found right. I believe it is thioacetone.
Yes, it might be that way. Oh yeah, you are right. Thiolacetone is what it is.
But why don't you fill everyone in on why this chemical has made this list?
This is the most stinky chemical known to mankind, or womankind for that matter. I'm not being sexist. Discovered in the late 1800s by accident in a place in Germany. I cannot find it now. Hang on, give me a sec.
Yes, one morning they were
working away on something else at the time.
They were actually working on perfume agents, believe it or not, when they discovered the worst smelling chemical in the world.
Yeah, so it was in 1889 in the German town of Freiburg, which is Freiburg. In case I'm saying that wrong, and I'm sorry if I am. And they were working on a related compound in this perfume factory, and they managed to synthesize some of this chemical in the process. The stench could be detected from half a kilometer away. So people half a kilometer away were vomiting up their guts, because that's basically how bad it was. It was so bad that it triggered an evacuation of the entire town just because of people vomiting uncontrollably. So, whilst this particular drug won't kill you, you probably would wish you were dead if you smelled it. Especially if you're up close. But you've got a story about this drug, haven't you? This drug.
Not chemical. This one. It was a different one.
Another one of the thiols.
But I can add to this. So, for anyone who doesn't know what a thiol is, while I bring up the actual chemical structure. Thiols is pretty much anything that is bonded to SH, or anything bonded to organics bonded to a sulfur.
Yeah, and sulfurs are pretty stinky.
Yes. Now, we often think about sulfur compounds, or you might think of sulfur compounds when you think of things that are really stinky, like hydrogen sulfide, the rotten egg gas. One of the reasons we probably find it so smelly, so nasty, is... Sorry, my computer is deciding to show me a whole bunch of random things. No, stop doing that. There we go. Is because it's also released in volcanic activity. So when and it's actually what a lot of animals use to know when to get away from natural disasters.
So we've evolved the
dislike. It's quite a bad smell.
We've evolved a dislike to it because it's a warning.
Yeah, and it's also, I think, associated with a lot of rotting chemicals as well. So you produce these thiol chemicals from rotting flesh and meat, which is something you don't want to go near because it'll make you sick. So it's why humans have a natural tendency to avoid these things.
Yes.
And so we already don't like them, but this is all it is. It's not very fancy.
You haven't shared it yet, Matt.
It is
yes, you have.
3 carbons, a bunch of hydrogens, and a sulfur up the top there. Now, all you need to do is switch that sulfur for an oxygen, and you have acetone, which is a chemical you'll find in pretty much everything: nail polish remover, glue, a lot of cleaning products.
Which is why its name ends in acetate.
I don't have it up. I've got a small vial of it in my room somewhere. It's such a common chemical. But you switch that oxygen for a sulfur, and now you have a chemical that will make people throw up hundreds of meters away from a single drop.
And
yes.
I mean, like I said, Matt's had, well, not direct experience, but he's worked in an area that had experience.
Not this one, it was another one that
with another one of the thiols, because they're all stinky. This is just
no,
the
it
worst.
wasn't. This was butyric acid. It's
yours was butyric acid.
But yeah, so the other one I was getting at, so butyric acid is not quite as worse as a thiol. Now, this chemical is not as strong, but it smells exactly like puke. It's 2 carbons longer than acetic acid, which is pretty much vinegar. So all you do is take vinegar and add on, make the chain a bit longer, and you get this. And it smells like puke, and I had to work in a lab once where they had an accident. Someone dropped a glass of this that must have smashed on the floor.
Yeah.
And even after you try cleaning it up, you can't get rid of the smell.
Because it eats into the carpet and the floor, and...
they had no carpet in the lab.
It would have been that lino.
Like the plastic lino floor? Yeah.
Sorry. It just eats
even
into
still, it seeped into something.
Yeah.
Like, they could... And so we're all there, and the professor walks in and doesn't say a thing. He just walks in, and you can always tell which lab coat the professor owns on the rack because it's always the one that's still clean. So the professors just visit the lab every now and then, and he didn't say a thing. And it got to the point where one of the postdocs, one of the people has a PhD, and they're working as kind of like a researcher. So they're like the assistant to the professor, actually turned to him and said, "Can you not smell this?" And he's like, "Yeah, but I couldn't tell if someone had thrown up, and I didn't want to be rude."
Well, that's kind of nice.
Because you can't tell the difference. This stuff does not smell friendly. But the weird thing is, all you take is it, and you take its equivalent alcohol, butanol, and you can react them together with some sulfuric acid, and you end up with butyl butanoate, which is the lovely flavor enhancer that's for banana.
Yeah.
So when you have lollies that have banana in it, they've actually taken butyric acid and reacted it with butanol to make this lovely ester. But if you break it in half, you end up with a chemical that smells like puke. Bad. And I don't know what it tastes like, and I have no intention of finding out.
No.
But the thing with thiols... But yeah, going back to the thiols for a moment, they're like a nasty class of compounds, like those SH compounds. I've worked with them in the lab as well. Actually, now that I know I said I didn't actually have a story, and now I remember I do have a story. I worked with a less potent version, significantly less potent version in one of the labs.
Yeah.
We had to do some lab thing. We're dealing with another nitrogen compound. Yes, nitrogen comes up again.
And that's your problem,
fairly common.
Because... it's easy to accidentally synthesize some of these things when you're doing other chemical processes.
Well, this one was no accident. This was deliberate, and somehow they let me. They make you got to do your own investigative part, and we were actually taking these organic molecules with nitrogens on the end and putting them onto metals, and then seeing what they looked like in spectrometers. So we'd shine light on them and see what happens. And we were going to see if we can tell differences. So I think we had copper and we're binding it. And I remember doing a research project where, and this is actually where I melted my hand, because this is why we had sulfur, is that sulfur's really good at binding to copper. So I was like, why don't I get a compound that ends in a sulfur and see if I can bind that? And then someone pointed out to me, we've got some of these, but you probably don't want to use them. The thiols are quite nasty. So I went to people and I started asking, and they're like, you probably don't want to use that one, but we have another thiol we can get you from the building. and they got me a whole container of this stuff.
Oh,
now one of the things you can do to avoid it spreading is work in a fume hood, which is basically a cupboard where they're sucking the gas up the back through filters. But we also had a vacuum pump because you have to synthesize these and then you have to get the fluids out. So you put them in like a little filter and then you suck the air through. But any vapor that comes off will go through the vacuum pump. So we had to be careful, even though the vacuum pump was meant to be pushed into the fume hood. We ran it through a bleach bubbler, so it bubbled it through bleach because that's really good at killing dials. Because bleach will kill off the smell. You want to get rid of these sulfur smelling compounds? Bleach will clear a lot of things. So I've got the bleach there. They brought me like industrial strength bleach too, like a just container of industrial.
They did not want the smell getting out.
No. I rinsed all the glassware with this stuff. I ran out, and they ended up having to go and buy like Coles brand bleach. But even still, like it was the strong stuff, but it worked. And then I'd rinsed all the glassware out, and I took the glassware to the sink. No one complained. I came back to the sink to clean up. People started complaining. I'd managed to get a trace amount on my finger, and because I've been standing at the fume hood and dealing with the smell, I was not noticing it. It was bad enough that people like 2 benches down were starting to complain about the smell from trace amounts left on my fingers.
Yeah.
The reaction still somewhat worked. I didn't do too badly for that, considering. But I'm surprised they let me. But it was senior lab, so and like we were careful. But yeah. And there was another student. The lab, one of the other research labs had. It was an exchange student. And he was producing some of these chemicals, some really nasty thiols. They set up a bleach bubbler, and all he had to do was connect it into the machine, and they already had it set up. Somehow he managed to undo the bleach bubbler and then ran this through. It was actually like a vacuum, just pulling this gas off, took the sulfur compound with it, and sprayed it into the lab. The chemistry building still has a unique smell to it. Like...
But chemistry buildings usually do have unique smells, though, because there's always the occasional accident that happens. You just hope it's not a deadly one. You'd much rather have the bad smell reaction happen by accident than, one of the other ones.
Yeah, I mean, one of the professors was telling me a story where he actually felt a bang 3 floors below because someone had something under the nitrogen pressure and the tank blew. No one was injured because no one was at it at the time, fortunately. But this blast was solid enough to carry through 3 floors of solid concrete building. Like this building is a chemical. It's designed to have labs in it. But it's also the other reason you put the organic labs on the top floor, and I'll leave that as to the chat as to why we put the seeing Nerdy's comment. As to why most chemistry departments, and I mean recently it's not something you do as much, but why you always put the organic labs on that top floor. It's not to do with the smell, actually, but there's a good reason. I want to see if anyone in the chat will get it, but Jen will probably fill us in later if we can't.
No, that's all right. Your story.
I'm trying to think of one. No, I'm going to see if people in the chat can get why we put our organic labs on the top floor. It's not it's a fairly sobering reason. But I'm wondering what chemical we want to try next, because I've been talking for ages now.
You have, but they've been good stories. What have we done? Dimethyl mercury.
Oh, no, we haven't done that one.
That's a good one. Well, not a good one, but it's a...
Yes, but I'm going to take this to make a good message about vaccines as well, because I can spin this that way as well.
Oh, now, I think that's a
we're all familiar... Yeah, so we're all familiar with mercury being dangerous. I don't think anybody here would say it was a safe chemical. But methyl mercury on its own is safe. It won't hurt you. In fact, there are people who have had mercury injected by accident, I'm hoping by accident in most cases, into their hands or into their body. Just the plain metal.
You've done people who walk on mercury because you can treat mercury as a non-Newtonian. As in, yeah. So
yeah.
if you hit a hard
It also
enough.
sit in your hand. You can sit in the palm of your hand. But the point of being able to inject it is that it will sit there. It won't react. It won't do anything. So you can come back a decade later and get an X-ray and see the mercury. So you could get an X-ray tattoo. I'm not recommending this. Don't get mercury tattoos. But you could get a tattoo that shows up in an X-ray.
Nerdy's giving you an answer, by the way.
Freddie Mercury is safe.
No, Nerdy's... No, before that. The one coming up now.
Yeah, it's actually very close.
Very close.
Not far off with that one. That is along the right lines.
Yeah, well, because you don't want explosions happening below other experiments. You want them at the top, away from.
Yeah, it's mainly that heat rises.
Rises, yeah.
So if you get the organic ones tend to be the more flammable stuff. So if you end up with labs that generally do distillations of things like hexane, acetone, ethanol, all these flammable chemicals. Hexane is a slightly lighter chemical than what you put in your car for petrol. It'll burn even better.
Yeah.
So, and you distill it, which means heating it. So
if it catches fire and it's a lower story, it just burns up through the entire building.
Yeah. So I think ANU lost the top floor of one of their buildings once.
Really?
They had that. Yeah, but it only took the top floor off because again, the heat
because
rises.
of course, I mean, all chem labs have huge amounts of sprinklers and
yes.
chemical retardant
and fire doors everywhere,
and fire doors and chemically retardant fire extinguishers and stuff like that. Because you have to in a chemistry lab, you have to have all the different types because you have to use the right one depending on what type of fire you've got.
Yes. So we have a bunch of them. I've actually, as part of my time in chemistry, and they like this for teaching, I have had training on how to use fire extinguishers. I've actually managed to put fires out. They were controlled ones where we had a firefighter come in and deliberately light fires, and we used the CO2 fire extinguishers. But so like I've gone through the process of that because it's a risk. But one of the main things they told us was do not try and put it out if you don't feel like it's safe. Like their biggest word of warning with a fire was it very quickly gets too hot, even a regular house fire. So unless you get to it, I think within the first 50 seconds, pretty much just forget about it. And they said, and that's why in all of the science buildings, the physics, chem, and any of the others I've had a chance to visit, you will never get into trouble if a fire starts in your fume hood if you were not doing something ridiculously stupid. If you accidentally spilt something over and it caught fire, they will not get you into trouble because they know that accidents happen and they'd rather people admit to accidents and take action that way rather than try and cover them up, because that's when you get injuries. When the fire starts and instead of evacuating, you try and put it out and you end up putting yourself there. So yes, my PSA announcement on that is, the best thing, particularly with industrial chemicals that you'll find here, you back out.
Yeah, Sandy's just saying she has to replace all her extinguishers. And please do that if you have fire extinguishers. Everyone should have one in their house anyway, but they don't last forever even if you don't use them.
Yeah, and water's not always good, particularly for electrical ones. The CO2 ones are fairly universal, but
in the house you're probably better off with the CO2.
That's most of the small ones I've seen have been CO2 ones anyway.
Well, they tend to do that now because water ones are just dangerous in a house fire because 9 times out of 10 they're going to be electrical, and
or they'll be
gas.
cooking based, so they'll be oil based, and if you push water on it, it's going to make
or you just spread it, or you're just going to disseminate a gas and not choke it because it just doesn't work.
It's like a CO2 powder. So as long as there's airflow, you're not in trouble from it. And the fire will be a bigger hazard. The firefighter was saying, you've got like less than 50 seconds before most fires are too hot to physically get close enough to put out. So you just
I like that.
Just open the airlock. Yes, yes. My spaceship is grounded at the moment.
Yeah, and dogs won. University practices would drop the contents of old-fashioned mercury thermometer into pints. You wouldn't make it to the toilet and shit where you sat. I mean, and that's the thing when we talk about how dangerous mercury is. In general, methyl mercury doesn't generally react with the human body too well. It's why you can have a drink of mercury, which is what they do.
No. This is methyl mercury.
Well, yeah.
No, the methyl mercury is worse.
Oh, the methyl mercury.
But dimethyl mercury is worse. Oh, yes. So dimethyl, yes.
The methyl mercury and mercury itself isn't too bad, but the dimethyl mercury.
Yeah. So what happens is, as you notice, going from mercury, which, as I said, you can even inject into no problems, to Nerdy's Comet, where you put one methyl group on it. Methyl group is just a CH3. It's organic.
Yeah.
What you're starting to do is to make these things fat soluble.
Yes.
Which means they can get into your body. And they're fat soluble, they can also pass through the blood-brain barrier, which is also pretty bad.
And that's where mercury does a lot of damage.
Which is, yes. And when you look at mercury in environments, so Sydney Harbour with all the mercury that's been dumped into the harbour there, yes, there's a lot of industrial waste. That's why they won't dredge Sydney Harbour. It was the old sodium hydroxide production facilities, I believe. They were a mercury process. Theoretically, it wasn't meant to leak mercury, but theory and practice are different things. So there's a bunch there. You don't want to do it. It's what happens when they become organic, when you start adding these things on. So when they're sitting in the environment, a bacteria can process them and they can turn them into these organic components. That's what gets into the kind of the biosystems, and it'll bioaccumulate
the fish and
So in fact, with fish, that's why farm fish are so much better, because you can monitor that. But also, they don't tend to be predators. Predators will tend to have more mercury in them. So that's why people say eating swordfish and marlin caught in certain areas are not great. Although you don't eat any fish in Sydney Harbour that is further inland or further in than the harbour bridge, because those fish stay permanently in that area that has mercury, whereas on the other side, they'll come and go, so they don't have as much mercury. So that's the warning I've been told. I should double check that one. So don't take my word for it exactly. You can double check everything I'm saying, but there's that one. However, once you add an extra methyl group and you get dimethyl mercury, that's when things get super dangerous.
And we can talk about Karen Wetterhahn, who was the first. The first case of a death with dimethyl mercury. People didn't realize that exactly how dangerous it was. In 1996, she spilt 2 drops of this substance on her glove, and didn't think anything of it because she thought, it'd be fine. Sorry,
was it nitrile or a latex glove?
They don't actually
one of those like proper chemical gloves.
No, it was latex. It was latex.
Latex, yeah.
It was a latex glove.
And she knew it was dangerous, so she took the glove off pretty much straight away.
Yeah, but she didn't wash down because she thought, I'll be safe because it didn't get through the glove. But it did. A couple of drops got through the glove onto her skin. It was a couple of months before she started exhibiting signs of the mercury poisoning, which was cognitive impairment and slurred speech and stuff like that. So she went to hospital about it to get it sorted out, fell into a coma, and after 5 months finally died. And 2 drops of mercury, of dimethyl mercury.
Yeah.
It's like dimethyl mercury, sorry.
That's why structures and what you attach to these things is so important, because it's not just, you've got mercury, it's what you put with it. Because mercury will replace a bunch of things in your system. I think calcium is one. That's why it'll get into your bones, so you start getting muscle aches. It'll get through into your brain, so that's where you get the impaired cognitive functions. So it's also where the term mad as a hatter comes from, because mercury was one of the first treatments. Well, it was used for felting of hats. That's why the hatters went mad. Yeah, but also it was one of the first treatments for syphilis. It was just mercury. You would use mercury, and it was good at killing the syphilis. It just wouldn't do you a lot of good.
It's one of those things, because syphilis also turns people crazy anyway. So how did you know if it was the mercury or the syphilis that had?
You'd probably take the mercury because it would take longer.
Yeah, it would take longer.
But the first antibiotic to ever be developed was not penicillin. It was a chemical to treat syphilis, and it was actually effective at it. The guy who did it was like the father of our modern method of selectively finding chemicals to treat specific diseases. And he found this compound. The only problem is that it decayed in oxygen over time, so it would become toxic after a while. So you had to be very careful. But it was the first time people had a proper drug targeted for treating a disease. And it's kind of where you get all of our modern medicine comes from, when we talk about, like, particularly with some of the AIDS treatments, when they found what it looks like and specifically made chemicals to treat it. If you want to look at why they, like even the COVID vaccine, how they did that, and they sequenced the genome and then started coming. That kind of started. I mean, it's never one person in science. It never works. But this was one of the founding people of it. I wish I could remember his name. It was because he knew the look how bad mercury was, and he was like, he actually played with dyes and bacteria, and different dyes affected different things, and he ended up using that to develop treatment for syphilis, which was running rampant in Europe at the time. It's quite a nasty disease that they had no treatment. But they did that. But to bring it onto a slightly lighter note is that mercury itself is not dangerous. It's the overall chemical. And there's another chemical that they used to put in vaccines called thiomersal, which had mercury in it, but the mercury was pretty much there just for the structure of the chemical. It was like a concrete building block, but it was so tightly bound to the chemical around it that it couldn't get out. It also was metabolized very quickly by your body, so your body would break it down and then flush it out. I think it was like a half-life of 6 hours, so it wouldn't last in your body for very long. It's about the same.
And it basically
it was about the same half-life
to increase the longevity of the vaccine. Basically, was the idea of it.
Yeah. It would not. You couldn't rip the mercury out, so you would never get mercury poisoning, no matter how much you gave this to. It had like a higher. I think the LD50 was higher than ethanol. So LD50, if anyone wants to know, is known as the lethal dose 50%. So how much of this chemical do you need to kill 50% of a population? It's normally done on rodents of some kind, or like small mammals. So rats or rabbits are the common ones I've seen in.
You're leading us to the next things, aren't you?
Maybe, but the LD50. So there are ways to check these things are dangerous, but yet a lot of anti-vaxxers would go out and say there's mercury in it. They put heavy metals in it. I'm like, okay, which ones? Like in the case of thiomersal, I've studied that. I did when I did my course in metals in medicine. Yeah. Well, it was like a metals course, and we had part of it was on metals in medicine. And like part of the exam was really cool. We would be given all these compounds with metals in the middle with all these surrounding organic compounds. And the question would be, what's this used for?
Yeah.
And so we would have to use our chemical knowledge to figure out, based on the metal and the surrounding elements, what it would be used for. So would it be like an MRI thing? Would it be a radioactive one that you used for imaging or for treatment? We would have to tell the difference between those, or was it like in those? Sorry, I just saw James.
Yeah, I have. I'll tag that.
Have you seen that?
Gigavax.
Yeah, have you? Yeah. Yeah, it was, I think, 8 doses of the Sputnik 5 one, and then you got to get like about a dozen doses of all the others. That's Gigavax. You just get a bit of everything. You inject them right into your biceps. Oh, wow. No, that's just a joke.
It sounds good.
But no, they actually took the thiomersal out because people were worried about the mercury in vaccines, despite the fact that it would actually increase the longevity of these vaccines. But it did not have a side effect. But people were worried about it, so they took it out just to be on the safe side. And so it's still an argument that, not that I go looking to hear people arguing for anti-vaxxers
talk
that
about
often.
Mercury all the time. It's the mercury. No modern vaccine has mercury in it. Well, no, I think there's one of them that does, because it was the only because they use it. Like I said, it's like a preservative. It makes it last longer.
Yeah.
And there's one vaccine that it's still the better one to use it for, but
yeah,
most vaccines do not.
But that's it. It's not. It's about what's around it. So you have to look at other stuff. But that's why when mercury gets out into the environment, as I said, bacteria in the soil will generally break it into the organic compounds that become dangerous. Whereas, thiomersal is made specifically in a lab. We know what we're looking at, and you can test for.
You're going to get
deliberately avoiding kettles.
That, aren't you?
Maybe I can be like a politician and just keep going with something else. Oh, what's that over there? But I believe you had something in mind, Jen, when you were talking about the next one. When I was talking about LD50s,
you were talking about LD50s. So we've done things that are poisonous, but in terms of them being poisonous along with other things. So
what about the most toxic chemical?
Oh. Well, I was going to go with potassium cyanide, but we can.
Oh, is that your submission for most toxic?
No, well, I don't think it is the most toxic, but it is incredibly toxic and has gained notoriety for being one of the most toxic.
Suicide pills.
Yeah.
You know, if you think about Hitler, his dog. Oh no, did he? No, he shot his dog.
So it is the thing of James Bond films, basically.
Yeah,
when the mouth bite down on your teeth and
they only have a few seconds. In real life, I'm not sure about the foam, but yeah, it actually is roughly that quick if it's in a large dose.
Well, it disables cellular respiration.
Ion channels, isn't it?
Yeah, and the cellular respiration. Yeah, so it stops cells from taking in oxygen. So
it stops cells from operating properly. It shuts down the channels, which if you look at a lot of the most toxic things out there, they affect ion channels, so they stop any charged particles moving over, and they'll just shut down some kind of chemical pump.
It stops ATP production.
Yeah, so like tetrodotoxin, which is the pufferfish one. That one is a sodium ion pump that it'll shut down.
Yeah.
But it's not the most toxic one.
Oh no.
The most toxic one is probably going to surprise some people. It's the botulinum toxin, the most toxic non-protein based, because you can talk about prions that can reproduce. But outside of that, the most toxic chemical known to man is Botox. People inject it into their faces to give themselves
because the
inability to show expression.
Yeah.
Yeah. But the thing about it is, because they started using this for cosmetics, and they use nanogram quantities, so like 10 to the minus 9. So you got 9 zeros before you reach any of these numbers after a gram, because any more than that is going to get dangerous. But because they started using it for cosmetics, they realized that it actually was good for medicine, and now there's a bunch of medical applications where you can actually use this. The most toxic chemical known to man has medical applications where it helps people. One of the ones I've heard was for cerebral palsy, because it can help with the muscles there.
Oh, because it acts like muscle relaxant, so...
Yeah, so it gives them a little bit more control over muscles. It can stop with chronic pain as well. Those are the ones I remember off the top of my head. There's a whole bunch more. Again, I am not actually a medical doctor, or even close to a medical doctor, so I can't remember all the specifics off my head.
If we're going to go other poisons, we've got batrachotoxin, which is the one that's from the certain frogs native to South America.
Oh yes, but it's also where we developed general anesthetic from.
It is.
It's the poison. It was actually they noticed that the poison darts were good at paralyzing people when knock them out.
Yeah, because it is up there with the ones we've already discussed as one of the most potent poisons known to man.
But if you slightly modify it, you get general anesthetics.
2 micrograms per kilogram is enough to be fatal.
I think, was it, for going back to Botox, I think a single gram can kill about 100,000 people.
Yeah. But
to give you an idea,
that's hard.
Yeah. But yeah, so, and it's also extracting. It's not an easy chemical to get your hands on or to deal with, but you get it from a bacteria. You harvested it from a bacteria. The botulinum toxin comes from the botulinum bacteria.
Yeah.
But to give you an idea, a single standard of alcohol has 10 grams of ethanol in it. That's how you define a standard.
Yeah.
And I don't know what that is in ounces for our non-SI unit friends, but yeah. So 1 gram of this will kill 100,000 people. It's about like that, somewhere on that order of magnitude.
Yeah.
That toxin, that they used it for general anesthetic, And if you want to look at like medical treatments, surgeries that save people's lives, that all came out of the ability to do general anesthetic. That's why when you look back at, say, World War One, or
because it acts as a
like
it's a neurotoxin that causes paralysis. So, and that's the reason why you end up being able to use an adaptive form of it as a anesthetic, which is kind of clever.
Apparently you actually experience the pain at the time, but it also affects the brain. You can't remember it, so you actually forget it. Like, it wipes the memory, which is why you generally won't wake up
because it messes up with your electrical signals in your brain, so you don't actually. Yeah.
But at the same time, you keep breathing.
Yes.
Which was a big problem.
Well, you do, provided they don't give you too much. Because otherwise you die. Because
yes. And
but I mean, the versions that we developed from these other things aren't quite the same. You know, it's where you go, oh, this can do that, because the chemical formula for it is C31H42N2O6. And I'm not going to draw hexagons because that's not my thing. But if you then look at some of the things that have been used for anesthetics, you'll probably find this. You'll find this slightly different. But we started with something in nature and built something ourselves. So,
which is where it's like 80% of our drugs come from.
It is. That's why it's dreadful that we're killing so many. Yeah. But why we're causing mass extinctions.
Yeah, we're also getting less and less now where the focus is moving in research to things that aren't found that way, despite the fact that it's actually the most effective way, because nature's had a 4 billion year head start on us. So it's got a lot more interesting chemistry than we do for the moment. Sandy's got a nasty story there. Yeah, but it's not easy, and it's also very difficult to judge because everyone will respond slightly differently to it. But before we had a lot of our modern general anesthetics, one of the chemicals they used to use a lot was chloroform. Chloroform. The joke about does this rag smell of chloroform to you was because it would knock you out. But it also, if you look at the list of possible hazards, it's like respiratory irritant, skin irritant, serious eye irritant, may cause cancer, organ damage from prolonged or repeated exposure, may cause cancer, may cause... it's this list of about a dozen things. But I can remember, because it was only a couple of years ago, that you'd walk around the lab with like 5 or 6 litre glass bottles of chloroform for your reactions, because it's a very common solvent, and it's not quite as nasty as some of the other things here. But they used to use that. So if you want to look at the American Civil War, that was what they used as an anesthetic, but it was not very good as anesthetic. So it's not the most effective thing, but it pretty much would just it caused brain damage in the process. It would just knock you out. But that was why surgery took so long before we were actually capable of doing any fancy surgery until the 20th century, was because we couldn't keep people still for long enough to be able to do those procedures. I mean, even still, it's not perfect, as we're trying to come up with better methods. And I mean, you got Sandy's story there, which is very unfortunate, and you got to be careful. But this is why we need research. The better we understand these chemicals, as nasty as all of these are, as nasty as all these are, we can take what's around us, we can take these, and a better understanding, we'll find uses for them, or we'll find ways of varying the chemicals so we can find a use for it. So as I said, because
we can look at the reactions that we get for certain things and go, okay, it's a bit strong, but maybe if we dial it, because we've got a fairly good idea how these things work. Like we know how to make things that are explosive. We know how to make acids, and we know how to make things that stink or things that are poisons, but we also know how to dial them back from where they are to be if we find a neurotoxin or some other sort of inhibitor that it could kill somebody, but we can find a use for that inhibitor for treating some disease, you can dial it back from there, figure out the dosage that helps a person, and help them. So it's not necessarily a bad thing having these things in nature. It's just bad when people use things the wrong way or have accidents with them.
Oh, I just saw Nerdy's comment. Just like the solution to dilution is. Oh, sorry. The solution to pollution is dilution.
Yeah.
Oh, that was. I remember that back in first year, someone was saying that. But yeah, you can't just tip everything down the sink because it doesn't always go very well.
No, well, I know that from experience in again in chem. Another story from in high school. God, I had a dreadful high school chemistry teacher. we're doing a whole heap of different experiments with potassium and with sodium in the class, and at the end of the class he goes, "I just tip everything down the sink." So you got two highly reactive chemicals with water, and we go, "Sure." Boom. Smoke and everything everywhere.
Whereas by the time I was going through, the OH&S had kicked in and they weren't allowed to do anything.
Yeah.
That
like was probably caused by people like us. In part.
No, it was probably the fact that the chemicals you're working with were dangerous. It just took a while before anyone cared enough to be like, we probably shouldn't.
It took a few kids getting hurt is what it comes down to.
Yeah, but I mean, we know a lot of the chemicals we've talked about are dangerous because someone made a mistake with them. Like the chemical N or substance N was, I think, made. Was that an accident, or they made it and they were like, "Wow, this is a lot stronger than we thought."
Sandy has a question.
I haven't really looked into that one. I would say, I'm trying to think. My brain is now going to whether regular Coke or Diet Coke would be worse.
Oh,
but I know they're incredibly acidic.
Yeah, especially that's the regular Coke, especially.
Yeah, I mean, because that's how they deal with the sugar.
Yeah, yeah. So you can eventually start dissolving copper in. I have etched circuit boards in Coke because you can do it. It takes a while, but you can do it. I mean, it's not a great solvent, but it does work.
But like here, that's how the one way you can clean coins in Australia because of the metals they're made of. I think I've got a coin hand. But yeah, you leave them in Coke for a while. I guess it depends what your coins are made of, but a lot of coins clean that way.
Well, you wouldn't want to put soft drinks down your sink because of the sugar content for a start. I mean, because it's a syrupy sugar and you end up with the sugar powders in this. It's a good way to increase build-up of extra sludges within you and block your drains. But
so why we shouldn't put oil down the sink either? Oils and fats don't do well either.
Because we end up creating they call them sludge whales or something like that in sewer systems.
Sludge whales or fatbergs.
Fatbergs, that's it, fatbergs.
I've heard of fatbergs.
Fatberg.
They had a giant one in London a number of years ago.
Yeah,
one of the TV shows.
Jeff would know all about
taking the piss out of it. But you tend to find them below areas of the city that have more restaurants.
Yeah, because of all the fat going in. But yeah, the sugar.
Yeah, because the deep fries or the hot plates, and they get all the gunk at the end of the day, and they tip it down the drain. And so even soap
Sandy Coke is definitely corrosive, and some of the other soft drinks are. It depends how they're made, but it does really depend on the soft drink.
I had something on that because they are corrosive. Depending on what the pipes are made of, they could possibly help leach metals out of the pipes too. Leach chemicals out of pipes.
Yeah, especially that's been a problem. Areas with old lead pipes and things like that, that'd be particularly bad.
Yeah, like if you want a good example of how not to have a water system, you can look up the the Flint, Michigan disaster, the water disaster there, because it was like the perfect chemical cocktail for like taking everything out of the pipes, and they ended up with like essentially heavy metal poisoning. A lot of people from it. Best solution for cleaning a barbecue. Do it while it's hot. Just regular water while it's hot. It's somewhat safe. It's much safer too.
Much safer, yeah.
This is what I do. It's actually what I did earlier tonight. I made barbecue. for family here before I started chatting to friends, and then I joined on here after that. So yeah, we we're cooking like there's 6 of us plus we wanted leftovers. So
Sandy, it depends on the type of system they have, because like some restaurants and things like that have special catchment systems in their drains, especially if you're dealing with fats and stuff like that, to help try and stop fatbergs and things like that. So now the thing you get is if you pour the soft drink down after the fat, you'll help dissolve the fat, but it'll eventually come back out again and get in the sewers, and you end up with problems anyway. So yeah, there are probably good reasons why they told you not to put the Coke. It's probably not going to dissolve anything in the system, but there's lots of good reasons for not tipping it down the sink.
But yeah, it's like a ridiculous, 16, is it 16 or 36 or 32 like teaspoons of sugar in a
it's an insane amount of sugar.
Like, and the reason that you don't it doesn't taste sickly sweet is because of the acids they put with it. So you've got the carbonic acid from the dissolved CO2, but also I think it's hydrogen phosphate, so phosphoric acid that they put with it. So H3PO4 from memory. Yeah, it's not a particularly strong acid, but it's the acid balances out the sweet taste, so it doesn't overpower. Which to me is like, just why not just put less?
Yeah, well, I mean that they have that problem with because they put a heap of salt in it to act as a preservative as well. So they have to put enough sugar to cover the salt as well. So you still have a sweet taste because of the amount of salt they put in it. It's just, surely you can come up with a
on that
solution.
note, I can also answer Sandy's question with Pepsi or Coke. There is some science. So a lot of people, when they do the taste testing, particularly if they show it in ads, between Pepsi and Coke, a lot of people will choose Pepsi Max. The reason why is because it is sweeter. It tastes sweeter. Now, I don't know whether it has more sugar or whether it's just the balance.
No, there's no sugar in it. It's artificial sweetener, and artificial sweeteners do actually taste sweeter. It's a different sweetener,
and so
they taste sweet.
In small quantities, sweeter things taste nicer, but when you're drinking a whole can and you have a larger volume, things that are less sweet are more pleasant. So when you do a taste test like that, people will say the Pepsi Max tastes better, but if you were told to drink a whole can or a bottle, people would probably go for other options like Coke instead of that one.
Not me.
So it depends on the volume.
But I don't. I mean, I like the extra caffeine, so I can taste the extra caffeine. So that's why I go with the Pepsi Max. Yeah.
Oh, I didn't know you taste the caffeine.
Oh yeah, you can taste the caffeine.
I can't drink. I don't drink coffee. I can't. Let caffeine be too much. But I have tea. I have the caffeine in that. Although, as James pointed out, the best way to have Coke or Pepsi, doesn't matter which one, just has to be cola flavored, is with rum. Particularly any spiced rum. With that. I have a few. One of the best ones I had, although this was probably overkill, was the El Dorado spiced. But I think that was overkill. I did that once. But Kraken, Captain Morgan, Admiral, Old Jays, if you want one with a bit of vanilla in there. I could make a channel on some of these.
I think we're having great discussions about this anyway. By the way, everyone, if you want to keep us all having nice stuff like this, support the channel. I do have a Patreon that's linked in the description. If you can afford to and you want to throw a few bucks this way, I'm hoping to get a slightly better setup so that we can do a few more fancy stuff with animations and audio and sound modifiers, and do better looking graphics for Matt and I, so when we sit opposite it can be even cooler. Help Matt out with his lighting and things like that. So every little bit helps, and to come up with some good production so we can do some nice stuff. And I'm planning on helping Matt a fair bit with some of his stuff as well, because I think Matt makes absolutely awesome content. So if anyone who's subbed to me, who watches me, who isn't subbed to Matt, go sub to Matt. He's down in the description.
Thank you very much.
As well.
And yeah, so working on my next video will be on aliens that we like. What would alien life in this solar system look like? Yeah. And you've already helped me a fair bit with that. I was already looking at some of the sources you sent. So that will be chemistry based. There'll be a bit of chemistry in that one. But I'm probably going to, I've been thinking about how to do that one. I think we're going to do like a like a half chemistry, like it'll be somewhat chemistry based because we need to know what we're looking for.
Organic.
But it'll be like a tour of the solar system. So we'll be going around the solar system and looking for the chemical systems that might support life.
And we're going to come up with some good graphics to support this for Matt, because he wants to make it like a documentary for this one. And so we're going to actually have a fly through the solar system, and we'll have...
although I've got a few people who've already... I've got two great volunteers already for helping me with voice recordings if I need extra audio. So I have that as well. Yeah, Randolph Richardson and Kitty have both volunteered.
Yeah, so it should be a brilliant video that Matt's working on.
I'm hoping so. I think, but I'm now worried I'm going to oversell it.
We'll help you get there, Matt. Don't worry. We'll sell this up because I'm going to make sure you get there. I've tried this documentary thing, and I really want to see somebody succeed with doing it because they're not easy to do. They're actually...
I think we've got the chat is now just thinking about their next drink.
There they are. We've got them onto the alcohols.
Although hot chocolate with a bit of Bailey's in it is great. Like flavor-wise, even ignoring the alcohol, it is quite nice.
I've got one more thing to add to our list. Dioxin. Or, what is it? 2378 tetra... chlorodiibenzopdioxin. Or just dioxin.
That just reminded me there is one other chemical we can add in, but
cool. We'll add another.
I kind of mentioned earlier.
So this is TCDD.
What is this one?
This is it's a byproduct of incomplete combustion. So anything that you've combusted in the presence of oxygen, the chemical causes lesions on the body and damages fatty organs like the liver, spleen, and intestines, and it's fat soluble. So what happens is it gets into your system, dissolves into your fat, and then as you burn up the fat, it releases more of it into your system. So instead of killing you instantly like a lot of other chemicals, it takes its time. So you can think you're okay, and a year or two later, you snuff it, poisoned by dioxin. It's actually one of the drugs that was used. I mean, not necessarily a year or two later. It depends how it's done. But it's one of the drugs that was known to be used. We're going back to bonds and spies and espionage. It was the old cane trick, where you stab somebody with the cane that had the poison injection in it, but it didn't kill you straight away because it got into your body fat, and then a couple of weeks later, as it reprocessed out of your system, that was when it killed you. And by that point, you've forgotten what's made you sick. You've forgotten about the person who might have you felt something when you walked past them beforehand. So it's that poison that was used to kill people slowly over time through assassination, and it was used in this way. So
wasn't that where they'd have they developed these little pellets that were like hollow with holes in it, and they'd fill it so you could actually like shoot a little dart.
Yeah, they basically had canes that had like a little mini gun mechanism in them, and they'd just basically walk up beside their thing and shoot them in the leg, and then keep going. And the person would go, "Oh, what was that?" And then a couple of weeks later, they'd die from the dioxin poison. It was also bad because there was a case of production of dioxin in a particular factory where they hadn't set up their protocols right, and they didn't realize until they'd been running for a couple of months that they were killing people because the chemicals had slowly got into the workers, and by the time they realized what was happening, they'd 6 or 7 people had died from dioxin poisoning, and I'm trying to remember where it was because it was a long time ago I read about it. So, but yeah, that was dioxin as well. So, what's what? Yeah, Nerdy likes the way I grin when I'm talking about poisons.
I swear I'm on a bunch of watch lists. That's why I keep getting pulled over at airports.
Yeah, the Bulgarians use ricin, which is a lot faster acting drug than dioxin. So yeah, you could get caught that way. But yeah, dioxin was used as a chemical to kill people because it took a long time to kill them. And you had one.
I was just going to mention when we talk about the really strong acids that there is one more that is incredibly strong but not dangerous. It's actually a very safe acid despite being one of the strongest acids in the world. Let me just bring up the name because I can't remember it. But it's a carborane superacid.
Okay.
So what it is there's certain chemicals in organic chemistry that are more stable and harder to pull apart because there's something known as conjugation. So it's where you have double, single, double bonds, and the electronics mean that the electrons get shared amongst all of them, and so it becomes really, really stable. You can't rip them apart easily. They're not reactive. And so what happens is instead of making like some little flat 2D structure, you essentially make the same 3D structure, like a ball of it, with boron. So the electrons can be spread over the whole
not a particularly pleasant chemical all on its own.
But in this way, what you do is then to the outsides of all the borons, except you've got... How many? Yeah, I think you've got one carbon. So you have all borons, one carbon. Yeah. To all the borons, you attach a fluorine.
Oh! Like I said before, most of these chemicals end up with a fluorine or a chlorine or a nitrogen.
However, because the fluorine-boron bonds are so strong, instead of being dangerous like everything we said before, they're quite happy as they are. So what happens is you have this little carbon sitting at the top and a hydrogen sticking off. I think there's another hydrogen floating around as well. Because that cage in the middle can push that electrons everywhere, it can release the hydrogen as a H+, so a proton off, and it can hide that electric charge. And because it's so stable and so happy like that, pretty much anything, you put it near anything and it will kick the hydrogen off to it. But because it's so stable, the anion doesn't want to do anything. So it's unlike the fluoroantimonic acid or the HF, where the anion, the fluoride, is doing so much damage. This one just floats around in solution or wherever you've got it as just this happy little molecule.
Fine. I'm happy. I've protonated. I'm fine.
I remember one of my lecturers was telling us about it. And the way he described it, he's like, it's so fun. Even my little kid could play with it. And then he put up a photo of his little baby. And he'd made a Molly-Mod kit where he'd made a model of the molecule. And the kid's like a little toddler holding it, like biting on one of the molecules. And I'm just like, that's a good way to put it. So that was like the exception to the rule. It's so strong it can protonate sulfuric acid. So if there's any nerds who are watching, you'll get what
which is what we were talking about before, but in a way that you can eat sulfuric acid, but this one doesn't eat it, it just protonates it.
It's so strong that it's like, I'm too acidic, here, sulfuric acid, you're not acidic enough, here, have an extra proton.
Yeah.
Which is something sulfuric acid doesn't like. But this thing is so strong. But yeah, it's fairly stable. But because of that, it becomes a really, really useful reagent for making some chemicals. And because it's not super dangerous, it's not as bad as working with some of these other chemicals. So you can do all these fancy reactions without blowing your lab up, without dissolving your arm off, without eating through a bathtub, without burning through concrete in the floor underneath. Yes. I did do a video on Schrodinger's cat. That was the last one I did. It was just a short one. But yeah, so yeah, there's all of those. But
Schrodinger's cat is so interesting. We'll do a quantum mechanics discussion sometime, because that would be good. No, because I know somebody we can have in who actually really knows the topic, and we could throw questions at them and learn stuff. So
that'll be better, because I'm better at asking questions in quantum mechanics. But I think Richard Feynman got it right when he said, I believe that no one understands quantum mechanics.
Yeah.
There was also, I think it was falsely attributed to him, but it was anyone who thinks they've understood quantum mechanics has clearly not understood quantum mechanics.
Yeah. But I think that's a bastardization of what he actually said. So,
I think what he said was, I think nobody understands quantum mechanics. But either way, it's still true, I think.
It's still true. Oh, yeah. Well, there are people who have a pretty good understanding of it, but I mean, it's not complete. So how can you have a full understanding of something that we know isn't complete? So yeah. But I'll have a talk and see if we can get and for the life of me I can't remember what his name is, but he's well in on quantum mechanics, and I'll see if we can get him in. There's a couple of other people that I've been trying in the background to get in for Matt and I to have a talk to, who are people who are big in astronomy, astrophysics, and those sort of topics, as well as nuclear physics, as well as quantum mechanics, as I said. So it'd be nice because then we can have a genuine discussion with people, and everyone can have a little bit of learning. A lot of it will probably go over my head. I'll be honest.
Quantum mechanics, even if especially it goes in, in my head, it comes out the other side. So in one ear and out the other.
In one ear and out the other, yeah.
Not my area. I deal with spectroscopy. Give me a laser or give me light, and I'm fine. I'll tell you what's in front of you. Quantum mechanics. But the annoying thing is quantum mechanics follows you everywhere.
Oh, yeah. And it can be everywhere all at once. These
dead and alive.
Yeah. I think we've gone through just about everything. Well, not everything. There's obviously a lot more chemical compounds than that. But I think we've frustrated everybody for 2 hours now. And it is getting late for Matt. So I want to say a big thank you to Matt for being my co-host for this, because this has been awesomely fun, and discussing these chemicals has been brilliant. I know some of them have been discussed before in videos, and I know Matt and I discussed a couple of them the other day on another stream, which is what led to doing this in the first place. But I think we've covered a couple that haven't been covered as well. So we've covered a few things there, and we may touch on other compounds that do things on another time, because there are lots of interesting chemical compounds, and I know that Navadia would like to join us to do a discussion like that at some point, so that would make a really interesting discussion as far as that goes. So again, Matt, thank you for being here. What else have you got coming up aside from aliens?
That's the main one. That's going to be the big project. So at the moment, that's what I'm working on. So yeah, probably it could be a little while before I get that one done, but that's what my main focus on.
In the meantime, we've
gone into a more severe lockdown.
You have.
So yeah.
So I mean, depending on how busy I am during the week and how busy you are during the week, I might even see if we can grab someone during the week and do one at some point. Maybe at a time that suits the Americans better. Because they're good fun to do, and I love this. There's nothing better than talking about science and disseminating science information.
Yeah, who doesn't love telling everyone else how to blow things up?
So yeah, thank you again to everybody in the chat. You've all been amazing. Thanks to Matt's mates who joined us and gave Matt hell, because that was a lot of fun. Thank you to my Patreons, Dog, who's in the chat, to Jaded Atheist, and to Chris, who were in the chat earlier. I don't know if either of them is still there or not. Jaded Atheist is. Thank you to Patreons. Thank you to anybody else who might become a Patreon in the future. I want to make more content like this. I know Matt does, and anything that comes in, hopefully it'll help with things that can either end up on my channel or Matt's channel, or however, whilst we're trying to educate people and have a bit of fun. So yeah, please join us on the next one. Keep an eye on Twitter, either with Matt or myself, or probably both of us is a good idea, and you'll see when things are coming up. And yeah, go subscribe to Matt. He's brilliant.
Thank you very much. Don't forget to hit the like down below.
Yeah, leave a like. We need likes, and subscribe if you're not already. So yeah, and we'll catch you on the next one. Bye, everyone.